So today we're talking about basic polynomials or polynomial basics. The first thing we talk about is coefficient. A coefficient is a number in front of the variable. For example, if we use the example of 2x squared plus 3, the coefficient of this equation, or one of the coefficients of this equation, would be 2. It is the number in front of a variable. The next thing we need to talk about is constants. What is a constant? A constant is a number with no variable. So using that same example as 2x squared plus 3, a constant is a number without a variable. So for this example, it'd be 3. Moving on with polynomial basics, we have the next thing we need to talk about is a term. What is a term? A term is a number, a variable, or a number and a variable multiplied together. So for example, if we use the same example as up above that we have here, we have 2x squared plus 3. We have two different terms. We have one that is 2x squared, a number and a variable multiplied together, separated by an addition sign. And then our second term is 3. Okay? Every term will be separated by addition or subtraction. Now, the reason why we need to know how many terms there are is because we can give them names based off their terms. So, type of polynomial is what we need to talk about next. The type of polynomial depends on how many terms there are. If there is one term, we call this a monomial. If there are two terms, like our example of above, we call it a binomial. And if there are three terms, we call it a trinomial. 4 terms, we just revert back to the original name and we say it's a polynomial. Now, one of the last things we need to know is the degree, what a polynomial degree is. The polynomial degree is defined by the highest exponent on a variable. So for example, they give us x to the 6th minus 5x cubed plus 2x squared minus 7. The degree is the highest exponent. So we're looking for this right here. So the degree is 6. Now what's going to happen is we're going to be given an equation. We're going to be asked to find these 5 basic things and be able to label them. So first off, let's look at problem number 6. We have negative 10b minus 1. Number of terms. We have one term right here. And we have our second term right here, separated by a subtraction symbol. So terms are 2. That means we can say its type. 2 goes back up to 2 terms, which is called a binomial. Next, we look at the degree. What is the highest exponent of the problem? In this case, you would see that the highest exponent doesn't exist, but it does have a power of 1. So our degree is 1. Our coefficients, any numbers in front of the variables. In this case, we have one number in front of the variable, stands about right here, and is negative 10. We have to take the operation with it. Our constant is what's in blue, so our constant is negative 1. Let's do 7 together also. We have negative 2a squared minus 2a plus 7. Number of terms. We have 1, 2, 3, separated by subtraction and addition signs this time. Next, we have the type. It'd be called a trinomial in this case. Degree, highest exponent. So we are looking for that right there. So that is a 2. Coefficient, any number in front of a variable. There's actually 2 on this one. So if we erase this real quick, our 2 coefficients are right here and right here. So -2, -2. Those are our 2 coefficients. Our constant comes from having a number without a variable, which is that one right there. So it is 7. So those are the 5 main parts of a polynomial. There's one more problem I want to do with you real quick. It's on the next page. It is actually number 8. So let's look at number 8. Number 8, number of terms. There's only one. So we have one term. The type is based off that term. It's called a monomial. Degree is off the highest exponent. The highest exponent is 1. Coefficients. Do we have any numbers in front of variables? We do not, so you would just say NA. Constants, though, we do have a constant in this case. It is -8. And so that is our constant. Okay, there's 3 other problems that you can practice on your own and check the notes online to make sure that you got correct. What we are going to do is we're going to jump down to adding and subtracting polynomials. First, we look at the operation in between the polynomial. Do that operation, add or subtract. So you do that operation and add or subtract to that polynomial. Make sure your solution is listed with the highest exponent first. Highest exponent term first and working your way down. So first off, 13. First step, we've got to distribute the 9 in. So 9 times 1 is 9. 9 times -8 is -72x. We bring down the -50x. And we combine like terms. I figured out what that fill in the blank was. It's supposed to be like terms for each polynomial. My bad. So we combine like terms. The only 2 I can combine are these 2. They're the only ones with variables. They're the only ones with x's. Okay, they have to be alike. They have to have the same variable, the same exponent. We both have x's. They both have an exponent of 1. So I combine those. -72 minus 50x is -122x plus a +9. Now the reason why I wrote it like this is we have to have the variable with the highest exponent first. That's what C means. After that, we are done. So moving on with that example, we have 6. First step, I'm going to multiply this -6 into both. So 4 minus 6 times 9, so minus 54a. -6 times -4 becomes a +24. Combine like terms. The only 2 things that I have alike are the constants. So -54a. Highest variable with the highest exponent goes first. Plus 28. You do have to show me one step on your homework. This would be considered one step. You have to show me that step. This is step 2. That's your answer. You have to show me that first step. So let's try a few. Let's continue with 15. 15, first step. Multiply the 4 in. I get 4p. And multiply the 4 into the 3. I get 12. Now I'm going to take this negative 2 that's in between and multiply that in with its negative. So I'm going to take this whole thing right here. I'm going to multiply it in. I get negative 10p. Negative 2 times 5 is negative 10. And the p just comes with it. Negative 2 times negative 3 is a positive 6. Now I have two things I can combine. I have a 4p and a negative 10p. I have 12 and 6. The variable with the highest exponent comes first. So 4 minus 10 is negative 6p. 12 plus 6 is 18. You are finished. That is how you distribute with the number out in front. So you distribute that number, combine like terms, and make sure the variable with the highest exponent comes first. If you do not have the variable with the highest exponent coming first, you will get the problem wrong. Let's look at 16. 16, I'm going to distribute the 5 in. So I get 15. 5 times negative 7 is negative 35x. Now, you can do this two ways. You can either just subtract that second polynomial, or you can distribute the negative in. I like to distribute the negative in because then it turns everything else to an addition sign. And all we do is we change the operations here. So if I times this negative in, I treat it like a negative 1, and I times it in, so I get negative 1. And then I do negative 1 times negative 6, which is positive 6. Then I don't have to worry about am I really subtracting or adding, things like that. Next, I combine like terms like I've been doing. So 15 and negative 1, x, or negative 35x and 6x. Variable with the highest exponent comes first. So negative 29x. 15 minus 1 is positive 14. You're done. So just to make sure we see that again, we will do 18, where we have that negative in between. So if you want to jump down to 18, I have nothing to distribute into that first polynomial. I'm going to times this negative, or this negative 1, into the second polynomial. So I'm going to rewrite the first one down. And then I take negative 1 times 6, which is negative 6. Negative 1 times negative 8, which is positive 8. And squared. I combine like terms. The variable with the highest exponent comes first. So negative 3 plus 8 is 5m squared. 5 minus 6 is negative 1. I am done. So that is adding and subtracting polynomials. I have to combine like terms. They have to be the exact same variable, the exact same exponent. Let's flip over the page. We are now on the next page. So let's look at 21 and 22. 21 and 22. We'll start there. 21 and 22. Now we are adding. We do the operation in between the two polynomials. So we're going to take this first polynomial of 6 minus 3k cubed minus 8k to the fourth plus 5 plus 7k to the fourth. When there's an addition sign in between the two sets of parentheses, what I like to do is just talk about what terms I can combine. So I can combine like terms. So I'm going to take the constant of 6 and combine it with the constant of 5. I'm going to take the negative 8k to the fourth and combine it with the positive 7k to the fourth. Outside of that, I can't combine anything. Now remember, the rule does apply. We have to have the variable with the highest exponent come first. So I'm going to take negative 8k to the fourth plus 7k to the fourth and get negative k to the fourth. Next, since I can't add anything to k cubed, it just comes down as negative 3k cubed. Next, I take 6 plus a positive 5 and get 11. My highest exponent is first. To see an example like that again, we'll do 22. 22 looks like this. I have this negative sign in between the first polynomial and the second polynomial. I treat it like a -1 and I'm going to distribute. Before I do that, I'm going to rewrite the first polynomial with its operations. I distribute that -1 into 6 and get -6p squared. I take that negative and I distribute it into 2p to the fourth and get -2p to the fourth. Now I go through and combine like terms, the same variable with the same exponent. I have a -7p to the fourth, and I can combine it with that -2p to the fourth. I have positive p squared and -6p squared. Remember, the variable with the highest exponent has to come first. So I take -7p to the fourth, I minus 2p to the fourth. I get -9p to the fourth. I take 3p squared, because that's the next highest exponent, and I minus it to -6p. I get -3p squared. And then 7p, since it's all by itself and it's positive, just comes down like that. And we are done. Let us look at one more example in this section. Let us look at 25. 25, I have to distribute two negatives. I have a negative right here and right here. So first step, rewrite the first polynomial, 3b squared plus 1. Distribute this negative in. Negative times a positive is a -4b to the fourth. Negative times a positive is a -2b. Negative times a positive is a -5. Negative times a negative is a positive 7b squared. That takes care of the middle polynomial. Now let's work with the right side, the very right side polynomial. We take this negative, we distribute it. We get a -8b cubed. Negative times positive. Negative times a negative is a positive 5b. And a negative times that, last one is a positive b to the fourth. Now we go through and combine all like terms. So let's start with the b squareds. I have 3b squared, and I can combine it with 7b squared. Let's talk about the constants. We have a positive 1 here. We'll combine it with this -5 right here, and that looks like it's it. Let's do b to the fourth. I have a -4b to the fourth. I can combine it with the positive b to the fourth over there. And last but not least, let's do -2b. I can combine that one with positive 5b. And if you look at it, -8b cubed has nothing to be able to combine with. Now, you got to remember, the variable with the highest exponent's got to come first. So we're going to start with the 4s. The 4s are the highest. -4b to the fourth plus a positive b to the fourth is -3b to the fourth. Next, we take the third. The third will come back down, bring its operation, so -8b to the third. Next is 3b squared plus 7b squared, which is 10b squared. And then we have the lone b's, -2b plus 5b is, -2, let's do that again, -2 plus 5b is a positive 3b. And then we have the constants, +1 minus 5 is -4. Our degrees go in descending order. We have a 4, 3, 2, 1, and 1 also. So that is combining like terms with polynomials, adding and subtracting polynomials. Trickiest part is making sure that negative in between each polynomial goes to everything on the inside. You have to make sure if you distribute something, it goes to everything on the inside of those parentheses. So what we're going to do now is we're going to flip over the page. We're going to talk about greatest common factoring or undistributing. So finding the greatest common factor, the GCF, of a coefficient or a term in a polynomial. Basically what this means is we pull out the biggest number. So the biggest number or biggest number of variables. So the whole goal is we're trying to find something in common between everything that's there and pulling it out front. So a couple of things that can help you is put the number and the variable in front of the parentheses. Whatever you pull out comes in front of the parentheses. Divide each term by the greatest common factor. Put what's left inside the parentheses. So let's look at 28 for an example. 28. I need to find the biggest number in common between 18 and 42. Okay, if you're good with your multiplication, you can easily hurry and do this in your head real quick. Okay, if you're not the best with multiplication, you can do this. What we do is we write out what times what equals 18. So we have 1 times 18, 2 times 9, 3 times 6, 4, no, and then we're back to 6 already, okay? Next, what we do is we write out what times what equals 42. 1 times 42, 2 times 21, 3 times 14, 4 doesn't work, 5 doesn't work, 6 times 7 does work, 8 doesn't work, 9 doesn't work, 11 doesn't work, 12 doesn't work also. Okay, 13, 14, we're already back to the beginning. So what we do is we find the biggest number that they have in common. Okay, what is the biggest number that we have in common when we wrote out the factors of 18 and the factors of 42? The biggest number that I see in common is this right here, is the 6. Those are the two biggest numbers that they have in common. So what they have is they have a 6 in common. They have 6 is their greatest common factor. So what we're going to do is we're going to pull that out. How you write your answer is you write 6, parentheses. Whatever's left over goes inside these parentheses. How do we know what's left over? We're going to divide everything by 6. We're going to take 18 divided by 6. 18 divided by 6 is 3. K to the 5th divided by 6 is just K to the 5th. We're going to leave it as is. 42 divided by 6 is 7. Now, to make sure you are correct in your answer, you look back inside the parentheses, and you should notice that none of the numbers should be similar. So 3 and 7 have nothing in common. In that case, we are done. So the number that you find out, the biggest number that you find that is common goes out in front of the parentheses. What's left over after you divide goes inside the parentheses. Basically what we're doing is if I distributed 6 back into this problem, I should get 18k to the 5th plus 42. That's kind of a way to check to see if you get it correct. If you look at 29, there are no numbers that are in common. If you look at x squared has no coefficient, well the coefficient of 1, but we don't want to pull out any 1s, and then we have negative 2x. So sometimes we can't pull out a number, but they do have a variable in common. In this case, they both have an x, and they both have at least one x. So what we are going to do is we're going to pull out an x. So x goes out in front of the parentheses. What's left over goes inside the parentheses. How we decide what's left over is we divide everything by x. Now x squared divided by x takes us back to the last 3 days. You subtract exponents. 2 minus 1 is 1, so we have an x left over. Negative 2x divided by x, well, we have an x on top and an x on bottom. So what's left over is x minus 2. Now, if I got the correct answer for the greatest common factor, all I would have to do is check to see if I distribute x back in. X times x is x squared. X times negative 2 is negative 2x. Guess what? I am correct. So with the greatest common factor, sometimes you're going to pull out the biggest number, and sometimes you're going to pull out the biggest number of variables. You have to check both. So let's try 31. 31 is a good example. It shows us both. It shows us the biggest number and biggest number of variables. Now, once again, let's start with numbers. Does 3 and 6 have anything in common? Yes, you could be shaking your head, yes. It has a 3 in common. If you can't see it right off the bat, write out what times what equals 3. 3 equals 1 times 3, and what times what equals 6. We have 1 times 6 and 2 times 3. You see right here that 3 and 3 are in common. So that's the start of what's going to go out in front of our parentheses. Now, before we actually start dividing by 3, we're going to see, hey, do they have any variables in common? In this case, they do. We have 3a to the 4th plus 6a cubed. So they have an a in common. But how many a's do they have in common? One term has a to the 4th. One term has a cubed. That means they have at least 3 a's in both terms. So we're going to pull out 3 a's. That means when I divide, I'm going to divide by 3a cubed and 3a cubed. So you deal with the numbers first. 3 divided by 3 is 1. You can write the 1 if you would like to. If not, you can leave it out. A to the 4th divided by a, we subtract exponents. 4 minus 3 is 1. We have an a left over. Plus 6 divided by 3 is 2. A cubed divided by a cubed. 3 minus 3 is 0. A to the 0 is 1. We have our answer. We can check it. 3a, if we multiply it back in, we should get the exact same starting equation. So that is greatest common factor, pulling out the biggest number or biggest number of variables that we can. With 32, let's talk about 32. If your leading coefficient, okay, so if the number in front of the variable with the highest exponent is a negative, you should also pull out the negative. This will help us when we start graphing here next unit. So let's look at 32. We'll do a couple more on this page and then we'll jump to another section. 32, we have negative 20x to the 5th plus 16x plus 6. So what we do with this one, if you can't see it right off the bat, write out what times what equals these numbers. So 20 equals 1 times 20, 2 times 10, 4 times 5. 16 equals 1 times 16, 2 times 8, 4 times 4. 6 equals 1 times 6, 2 times 3. What number do they all have in common? It looks like right here we all have a 2 in common. So we're going to pull that out. And since negative 20 is our leading coefficient, it's in front of the variable with the highest exponent, we're going to pull out a negative 2 also. Now, before we start dividing, we have to make sure that they have no other things in common. If you look at their variables, we have x to the 5th, we have x, but 6 is a constant. It doesn't have a variable. So not all 3 terms have a variable in common. So we can't pull any variables out. So we're just going to divide everything by negative 2. Well, negative 20 divided by negative 2 is a positive 10. X to the 5th just comes down. Positive 16 divided by negative 2 is a negative 8. The x just comes with it. Positive 6 divided by negative 2 is a negative 3. And that right there We have nothing else in common. We have a 10, 8, and 3. There's nothing in common with those. Not all of them have x's. So we are golden. Let us look at 37. Let us look at 37 for greatest common factor. 37, we start with numbers. Always start with numbers. So with 37, we're going to start writing out what times what equals 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 no, 8 no. We're back here. We write out what times what equals 30. 1 and 30, 2 and 15, 3 and 10, 4 no, 5 and 6, 7 no, 8 no, 9 no, and then what times what equals 18? 1 and 18, 2 and 9, 3 and 3, or not 3 and 3, 3 and 6, sorry. 4 no, 5 no. So what number do they have in common with all of them? It looks like the biggest number that they have in common is 6. They all have a 6 in common. So that's the first thing we're going to try and pull out is a 6. Now we look at variables. Do they all have x's? Yes, every term does have an x. How many do they have? Well, the first one right here has 7. This one has 4, and this one has 2. So the most that they all have in common is 2 x's. We're going to pull out an x squared. Y, let's look at the y's. Y to the 6th, y to the 5th, y cubed. The most that they all have is y cubed. We set up our parentheses. We divide by what we pulled out. So 6x squared y cubed. Divide by 6x squared y cubed. Divide by 6x squared y cubed. 60 divided by 6 is 10. Remember, we're subtracting exponents when we deal with variables. 7 minus 2 is 5. Might need a bigger set of parentheses. Let's erase that until we're done. Y to the 6 divided by y cubed. 6 minus 3 is 3. Next, we have our next term. Negative 30 divided by 6 is negative 5. X to the 4th. Divided by x squared, we take 4 minus 2, we give x squared. Let's rewrite that 35. X squared. Y to the 5th minus, or divided by y cubed is 5 minus 3, so y squared. Negative 18 divided by 6 is negative 3. X squared divided by x squared. 2 minus 2 is 0, so that's 1. 3 minus 3 is 0. So there's our end of our parentheses right there. So our answer is this. Pulling out the biggest number or biggest number of variables in common is what we are doing. Next section, we're going to talk about multiplying polynomials. That is what's on the next page. If you'll take your time and flip your notes to the next page. When multiplying polynomials, multiply the first term of the first polynomial with the first term of the second. Multiply the second term of the first polynomial with the second term in the second polynomial. Sorry, I might have gotten those backwards. change this, the first second to first. So you take the first term, you multiply it by the first term, you take the first term again, multiply it by the second term. You continue the process if necessary, remember your signs, combine all like terms. Basically, there's a word that you can use. It's called FOIL. Okay, the S stands for first, the O stands for outsides, the I stands for the insides, the L stands for last. If we use FOIL on 40, the first terms are 5n times n. So 5n times n is 5n squared. Remember, when you multiply variables, you add exponents. The O in FOIL stands for outsides. We take 5n times 3, which is negative 15n. The I stands for insides, so negative 8 times n is negative 8n. And the L stands for the last, so negative 8 times negative 3, you get positive 24. Last step, combine like terms. Make sure the variable with the highest exponent comes first. We have 5n squared, negative 15n minus 8 is negative 23n plus 24. You are done at that moment. The reason why we didn't do 39 is it's just a distribution, okay, times negative 4n. But let's look at a few more examples that look like this. Let's jump down to 42. 42, we use that FOIL word. If you want to write it, you can write it off to the side again. FOIL, first terms. So negative 6x times x is 6x squared. 6x times 4 is positive 24x. So we did first, we did outside, that's the O. I is the inside, negative 4x. And the L is the last, negative 4 times 4 is negative 16. Combine like terms. Make sure the variable with the highest exponent goes first. Now, before we get down to our last couple problems that we are going to do, we need to look at examples like 43 and 44. With these ones, I like to reference back to x squared. What does x squared really look like? It looks like this, x times x. So we are taking the same thing, which is an x, and timesing it by itself, which is an x. This reads the same way. We take x plus 6 squared. So that means I need to take an x plus 6 times itself, x plus 6. That gets rid of the square. Now we just FOIL. First, x times x is x squared. Outside, x times 6 is 6x. 6, or the inside, is 6 times x, which is 6x. And then 6 times 6 is 36. Combine like terms. We get x squared plus 12x plus 36. And you are finished there. Now, if by chance you forget to do the middle term, you will get the problem wrong. Okay, you can't just do x times x, 6 times 6, and call it good. There is a chance you can do that in a problem that is called the difference of squares, but we don't talk about that just yet. So 44, I'll set up 44 for you, but I won't solve it. The square just means itself times itself. So 2b minus 3 times 2b minus 3. Okay, and then you take the FOIL and multiply it out. I do want to talk about one of the bottom problems. Let's do 46. 46 and 45 are very similar. Start with the first term on the left. Multiply it into the first term of the right polynomial. So 4b squared times 2b. We get 8b cubed. We take 4b and multiply it into 1 and get 4b squared. Next, I'm going to take the second term, negative 4b, and multiply that into 2b and get negative 8b squared. Remember, when you multiply by variables, you add exponents. I take negative 4 and multiply it into 1 and get negative 4b. The 2, I take the negative 2 and I multiply it into this one, or the 2b. I get negative 4b. I take negative 2, multiply it into the 1, and get negative 2. Next, I combine like terms. Those two are alike. Oh, you can't really see yellow. Let's do, can you see green maybe? Then those two are alike. The variable with the highest exponent comes first. So we have 8b cubed plus 4b squared minus 8b squared. So let's erase that plus sign. And we get negative 4b squared. And then we have negative 4b minus 4b is negative 8b. We're getting more negative. And then our last is our constant at negative 2. We are finished with that problem. 45 is very similar to the 46. You would just start with n and multiply it in, and then start with 7 and multiply it in. Okay, 46 and 45 are very similar. Let's do 45 just to be safe, and then we'll pass out your homework. So with 45, you take n, you times it in. So we get n times 3n squared, which is 3n cubed. You add exponents. 1 plus 2 is 3. You take n, you times it in here, you get negative 6n squared. You take n times 4 and get negative 4n. 7, you multiply in, you get 7 times 3, which is a positive 21n squared. 7 times 6 is a negative 42n. Cutoff point between that next problem. 7 times 4 is a negative 28. We combine like terms. So we have these two that we can combine, and these two. Variable with the highest exponent comes first. So 3n cubed minus, we're going to do the n squares next, negative 6n squared plus 21n squared. So we have plus 15n squared, negative 6 plus 21. And then we have negative 4n minus 42n, which is negative 46n. And then minus 28 goes on the end. The exponents are in descending order. 3, 2, 1, and technically on the variable, there's nothing behind 28. It's a constant. That is it. You have the rest of the time to work on the homework. Good luck, and let me know if you have any questions.